In graph 7.5, we illustrated income and substitution effects for an increase in the price of gasoline, and we assumed that gasoline was a normal good. We'll now consider the case where gasoline is an inferior good for a consumer, and we'll see that there are two different kinds of inferior goods that emerge. We begin by illustrating the original blue budget constraint and the final magenta budget constraint that emerges after an increase in the price of gasoline has made driving around more expensive. We then illustrate the original optimal bundle A for this consumer by showing a tangency between an indifference curve and the original blue budget constraint. We then isolate the substitution effect by drawing in the compensated budget, which is simply the final budget constraint shifted out parallel until it is tangent to the original indifference curve. This illustrates the consumer's change in behavior that is solely due to the fact that trade-offs have changed, rather than the fact that her real income or her real well-being has changed. Notice that so far we have not had to invoke anything about whether gasoline is a normal or an inferior good. Substitution effects always operate in the same way, whether goods are normal or inferior. To isolate a pure income effect, we always need two parallel budget constraints to compare. Here we have the green compensated budget and the magenta final budget. On the green budget, the optimal bundle is B. If gasoline is an inferior good, then as we decrease the consumer's income from the green to the magenta budget, the consumer will end up purchasing more gasoline. That's just a definition of an inferior good. An inferior goods consumption changes in the opposite direction of income. Thus, the final bundle C has to lie to the right of point B. It could lie to the right of point A, but for now we'll place it in between points B and A. The substitution effect is the consumer's move from bundle A to bundle B, and the income effect is the move from bundle B to bundle C. Thus, the substitution effect causes the consumer to consume less gasoline, and the income effect now causes the consumer to consume more gasoline. For now, since we've placed bundle C in between B and A, the substitution effect outweighs the income effect, and the consumer ends up consuming less gasoline at point C than she did originally at point A. We will call an inferior good whose substitution effect is larger than its income effect a regular inferior good. We now again begin with the original optimal bundle A, and then illustrate the substitution effect by drawing in the compensated budget as well as bundle B. The substitution effect, as always, says consume less of the good that's become relatively more expensive, miles driven in our case, and more of the good that's become relatively cheaper, other goods consumption in our case. But now we'll not only assume that gasoline is an inferior good, we'll also assume that its income effect is so large that it outweighs the substitution effect. In other words, bundle C ends up not just to the right of bundle B, but also to the right of bundle A. The substitution effect takes this consumer from bundle A to bundle B, and the income effect then takes her from bundle B to bundle C. Notice that this says something fairly dramatic. It says that as the price of gasoline went up, this consumer actually ends up driving more than she did originally at bundle A. Such goods are exceedingly rare in the real world, and some examples are given in the text. We call such goods Giffen goods, to differentiate them from regular inferior goods, where, although the income effect pushes in the opposite direction of the substitution effect, it is still the case that an increase in the price of a good causes overall consumption to decrease. It often seems at first like there's more going on in these graphs than there actually is. Really, there are only two things going on. First, we find the substitution effect along the consumer's original indifference curve. Substitution effects always do the same things. They always point in the direction of less consumption of the good that's become relatively more expensive, although the size of the substitution effect will depend on the degree of substitutability that is built into the indifference curve. Second, once we've identified the substitution effect, we already have a compensated budget in our graph, and that compensated budget is parallel to the consumer's final budget. Whenever we see two parallel budgets, we know that we can identify a pure income effect, because parallel budgets represent pure income changes. Thus, once we get to bundle B and the substitution effect, we can now identify the income effect by using whatever it is that we know about a good, whether it is normal or inferior or given. Keep in mind, though, that as you talk about an income effect, you're talking about switches between the two parallel budgets, and the optimal bundle on the compensated budget is bundle B, not bundle A. Thus, as you locate bundle C using an income effect, you're locating bundle C relative to bundle B, not relative to bundle A.